In this session, I will discuss about how to check your environment, whether your environment is preloaded with the compiler or not, and then if your environment is ready for the CUDA program compilation, then we will check whether a machine is ready with the GPU is or not, and if the GPU is ready. So, then we will see how to execute the program on the GPU. In case GPU is not available on your machine, then how you can allocate the GPU for your execution of the program. So, basically we are accessing one of the NSM cluster for this experimentation, or you can say the lab practice. So, we will use two methods and we will show you how you can access the resources interactively and how you can execute your application with the help of Slump scheduler. We have developed a few set of programs. So, what are the concept we have learned throughout this course? So, on each concept we have developed some programs, and these programs are available in the provided GitHub link. So, learners can visit this link and they can clone the entire programs in their environment wherever they want to execute these programs. We have maintained the order of the program, so that learners can easily learn in a step wise manner. So, now we will start with the interactive mode. So, first of all we will log into the cluster and we will see whether the environment is set up for the CUDA program execution or not. So, here you can see that we have entered in one of the cluster, NSM cluster we are using for this lab, and right now we are in the login node, and in basically in a big cluster there are not a single login node, there are multiple login nodes. So, we have by default whenever you try to access the cluster, it automatically land you one of the available login nodes. So, whenever we have login, so it is taken me to the login node 5, and in this login node we have the programs, entire program which are available in a GitHub repository. The same programs we have cloned here in a one particular directory, that is CUDA_codes. If you want to see where we have copied this program, by using the pwd command we can check the entire path where the codes are available. Now, first thing, as I mentioned, first of all we have to check whether the CUDA compiler is available or not on login node. So, command is which nvcc. If we run this command, where nvcc is a compiler and which is a Linux command, and if compiler is available, and it will return the information about the binaries are available. So, you can see the bin/nvc. Now, we will check the version of the compiler. So, this is a command nvcc -- version. So, it will give you the detail about the version of the compiler which is installed, or you can say if it is available on the current machine. Now, we will run nvidia-smi command, nvidia-smi command, and this command will help to find the GPUs that are connected on the machine. So, currently you can see that it is whenever I am executing this command nvidia-smi and it is returning that command not found. The meaning is that currently I am using the login 05 and these nodes are helpful for the login purpose. They are not used for the computation purpose and this login node does not have any GPU cards installed. But here you can compile your programs. So, in the first program I will show you, I am going to compile here is 01 device underscore info.cu, this is a file name. So, how to compile? You have to use NVCC compiler, then the source file name. In my case, it is a 01.device underscore info.cu. Cu is indicating that is a CUDA file, and then hyphen O is placed to produce the output file. And for reference, you can assign any name as per your convenient, but for my convenience, I have given the name like 01 dot device underscore info. Name can be same, but you can check the difference in extension. One is .cu is a source file. When it will be compiled, it will generate the another file with the name of 01 dot device dot info, and learners can change this as per their own convenient. Let us compile. Now, it is not throwing any error. So, we can assume that compilation is successful, but when we check the compilation is successful or not, we have to just type the ls command, is a list command, and then you can see that one new file has been added here with a green color. So, these green color files basically indicate that they are the executable files in Linux system. So, now let us execute this program on the login node itself. We know that their GPUs are not available. So, we will see whether it will run or not. So, just as I executed this command on login node, it is indicating that there is a no device supporting the CUDA. As I already mentioned, when we have executed the nvidia-smi command, it has already told me that in login node GPU cards are not available. Now, we have to allocate one of the GPU node to run this executable. So, just check, just see how we have to allocate the GPU interactively. So, we are just copying this command. So, you can just see there is a salloc command is there, and with salloc command you have to specify the number of nodes, hyphen node is a parameter, and you have to specify how many nodes you are required. So, I am requesting only one node. Then I am specifying the another parameter, that is hyphen time, and I have requested this node for 1 hour. After that, hyphen grace parameter is used to request the GPU, and colon 1 is basically indicating that I requesting only the one GPU. The card may have one GPU, two GPU or more GPUs may be available on the same card. So, we are requesting one GPU for 1 hour. So, in our cluster basically we use a reservation concept for so that we can identify what purpose these nodes are allocated for. So, in reservation parameter the nptel is written. So, we have already created this pool of reservation. So, it is necessary to specify that from which reservation pool you are requesting these resources. So, after when you execute this command, you will the next command it will generate is that slog granted the job allocation with one of the job ID. So, that is indicating that one GPU node is allocated. So, now we will see which GPU node is allocated to us against this job ID. So, for this you have to run the slum command, that is sq space hyphen me, and just check where this job ID is. So, job ID is 7472489 and Q is interactive, and you can see the node list. So, against this job ID one GPU node RP GPU 027 is assigned to this particular user. Now we can go to this allocated GPU node with the help of SSH command. So, now when you move to this GPU node, you can see that we have the login node, we have changed the login node to RP GPU 027. So, earlier we was on login node, now we are on GPU node, but at the same time we are at a home directory. So, we have to go to the directory where my programs are available. So, here you can see that the executable file we have just generated, that is available. So, now we are going to execute this executable. So, when we have executed this executable on login node, so it has returned the message that there is no device supporting CUDA. So, now we are on the GPU node. So, same program we are going to run and we will see what it generates. So, here you can see that when we have taken the node interactively, so entire node is allocated to me, and when entire node is allocated, so then there are two devices, each node we have a 2 GPU cards, and you can see that device 0. This device 0 is indicating that the GPU card, which GPU card is available on the compute node, that is NVIDIA A100 with 80 GB, and it is placed on the PCIe slot. And after that, what are the information it is providing, that I have mentioned in my program, because of that reason it is providing. So, similarly, there is another device, device 1, you can see the same information is providing for the second device as well. So, this is a way you can allocate the GPU node interactively in the cluster, and you can execute your program on the GPU node. Important thing you have to remember, whenever you do the compilation of your CUDA file, that must be done on the login node, and when you want to execute the binaries, that must be done on the GPU nodes. So, this is one of the way you can access the GPU node interactively, and you can perform your lab experimentation. Now, I will discuss the another method to access the cluster with the help of the slum scheduler. So, now first of all we are at the GPU node. So, we are just exiting from GPU node and we are going back to the login node from where we have come to the GPU node. To use the slum scheduler, we have to develop one script. So, just check the script, what the information is mentioned in the script. In this script, you can see the first line, that is a mandatory line, and after that the hash sbatch in caps is a command that basically understand by the slum scheduler. And hyphen hyphen node, if you remember the interactive way, we have passed this parameter hyphen hyphen node equal to 1 in interactively, but the same parameter I am passing with the sbatch command. I am requesting only one node. After that, the second sbatch command is telling that you just assign the name to your job. So, the parameter to assign the name to the job is the hyphen hyphen job hyphen name. After that, you can see the few sbatch command, that is a hyphen hyphen output and hyphen hyphen error. So, here you can see that the %sign j dot out and j dot error. So, j basically indicating the job name which I have assigned nptel in this case. So, whenever the job will be completed, it will generate the two files, one is output file and another one is a error file. The name of these files will be allocated with the job IDs. Now, this is sbatch hyphen hyphen time. So, if you remember, the time parameter is used for reserving this particular node for the particular time duration. So, I requested here for 1 hour, and then the next command sbatch is a gress GPU. So, here I am requesting only one GPU, and the same reservation parameter I am using. So, my reservation name is nptel. After that, whenever I will execute this slum script, I want to go to the directory where my programs are available, and after that whatever the binaries we have already generated, that binary has to be provided with the dot slash the name of the binary. Now, just save this file and now we are going to launch this slum script and we will see that what it generates. So, to launch this script we have to use the sbatch command. So, sbatch is a slum script command and the slum underscore script dot sh is a script that we have prepared and we have assigned name to that file. So, whenever the sbatch command will be executed, it will indicate the particular job ID. So, now we will see that ls, with the help of ls command, you can see that this with this job ID it has generated the two files as I already mentioned, that error file and output file. If any error occur during the execution of this script or application, then it will be recorded in the error file. If there is no error, a job has successfully completed, then output will be recorded in the .out file. So, let us check one by one. So, we are just checking the error file. So, error file is totally there is nothing in this error file, that means error is not generated. So, now I will check the output file. So, some information is available in the output file. So, you can check that the slum submit directory, that is indicating that from where the code has been launched, what partition it is has been launched, the task PID, some information it is giving you, right. And if you see the line, this indicating that there is a one device supporting the CUDA. So, point to be noted here is that when we have requested the GPU node interactively, so it is allocating the compute node, complete node. Even I am not using the second GPU, but it is allocating that GPU as well, and no other user can use that GPU. But when I am using the slum, the same output I am getting, it is allocating only one GPU to me. That means, if other user comes and requests the GPU through the slum, then slum will provide the access to the another GPU to another user. And the information that is mentioned, that is same as we have already seen in the interactive case. So, I hope that the learners can use these two methods as per their convenient to use the GPU resources. In our case, we have a cluster, but it is quite possible in your case your machine might have, or your laptop if you are using that might have the CUDA support. Or another way, if you want to access the GPUs, then you can use any cloud infrastructure, those who are providing the GPU resources for learning purpose. So, you can visit those cloud infrastructure and request for the GPU. But procedure for checking the environment about the compiler and availability of the GPU, the commands are same. So, now I will discuss few programs one by one. So, first I will discuss about the device info program which we have just executed. So, using the nano editor, we are just open this file. So, you can see that. So, we have written in the program in such a manner that if whenever we execute this program on any machine which does not have a GPU support, then it will tell me, indicate me that there is a no device supporting CUDA. In case if I run this code on any machine that have a GPU, then I wanted to know its major and minor version. So, you can see if device is available, then print the major and minor version of it. So, major and minor version is basically indicating the micro architectural changes in that particular GPU has. Now, you can see this some print statements, and what are the information this file was printing, it is coming from this print statements. So, in this print statement you can see that we are using the device property dot measure attribute, it is giving the major and minor number. Apart from that, if I wanted to check how much of the global memory is present, so you can use this attribute. If you able to recall, I had discussed the device query functions. So, these are the also device query functions in a C program. You can apply these functions or property functions that is already defined to get the information about the underlying GPU. Suppose if I wanted to know how much of the multiprocessor are available or SM counts on underlying GPU. So, you can see that this highlighted part, device property dot multiprocessor count, this is a function is already defined in CUDA programming model. So, you can directly use that and it can generate the information about the underlying GPU. So, this kind of information is very useful if you have a good understanding how the device query functions can be used and how you can get the information about the underlying GPU. So, it will help you to get more information with the help of the program rather than reading the manuals. Now, I am going to discuss the next program. Next program is going to be the Hello World program.